Okay, here's our video on finding unknown lengths. Or widths, finding unknown lengths and widths, and area. So let's first talk about area. What is area? So we're going to talk a lot about area in other videos, especially when we talk about geometry. But let's just go over something very basic. So if I had, well, if you had, or anybody had, if we had this living room, or room, any room, right? And we know that this room was, let's say it was 5 feet by 10 feet. Remember the word by? We used the word by before for multiplication. You could find the area of this room, right? Let's say we wanted to get a rug. We need to know the area of the floor so we can get the rug, the proper rug. So the area right here is just 10 times 5. It's the length times the width, right? So it's 10 by 5. That's what they'll say at the rug store, right? The carpet store. But we don't use by. We say by, but we used to use times when we're talking about by. A 10 by 5 room, 10 by 5 with that multiplication symbol. And as we said, it's 50. It's not just 50 though. We have to know the measurement. So let's say this was feet, 5 feet by 10 feet. We would say it's 50 feet squared. That's the area. That's what we can fill on the floor, right? So let me do another one. Let's bring this up. So let's say we had another room here, and we want to get tiles or a rug, whatever it is. And of course we need to know the measurements. And there's a word we're going to use, dimensions. We need to know the dimensions. And that is, what are the dimensions, the measurements, right? That's another word for the measurements. And if this was 6 feet, right, and this was 12 feet, well, to get the area, we need to do what? Who remembers? 12 by 5, and what does by mean? Times. 12 times 6, right? So this would be 12 times 6. And of course the measurement will be feet. So what do you think the area of this floor is? 72, right. So this is 72 feet. And we're going to put that little 2 there. That means squared. Area is always squared. 72 feet squared. So if we go to the carpet store and he goes, well, what's the area of your floor? And you'll say, well, it's 72 feet squared. And he'll give you a rug that's 72 feet squared. Now you can also write it like this, 72 square feet. Right, whatever way you like. 72 square feet. So now that we know area, let's look at some questions to find unknown lengths. And by the way, we see this rectangle here. This is a rectangle. A rectangle, the area of a rectangle is just the length times the width. This is the length times the width. Right? 12 times 6. 12 times 6. And we'll talk about that in geometry when we talk more about geometry later. Okay, so here we have a problem. Here, let's say we have a room, right? And let's say we know the area already. Let's say the area was 90 square feet. So SQ could be square feet, right? Or we can say 90 feet. Do you remember? Put the little 2, right? Can't see it there, but there it is. The little 2 on top for 90 feet squared. So let's say we knew this is the area. We already know the area. And here we're saying the width is 2/5 the length. It's 2/5 of, remember of is times, right? It's 2/5 the length. In other words, it's shorter than the length. It's 2/5 of it. So this is the width, and there's the length. By the way, normally what goes on is when you're saying the area, when you're doing the dimensions, remember we said by, it's going to be the width first. It's always width first. Width by length. So back here, remember we said 10 by 5. It's actually, even though you're going to get the same answer, actually it should be written 5 by 10. Okay, so not 10 by 5, even though that's the same answer. You'll get the same answer. It's always width. That's a bad W, right? It's always the width times the length to get the area. So it's width times length, width by length, right? So in this case, it would be 5 by 10. That's the dimensions. Remember the word dimensions. So let's go back to this problem. We have the width by the length, width times length. We know the width is smaller than the length. It's 2/5 of the length. So what we should do here is, it's guess and check. We're using guess and check. Guess and check. Right? So the first thing we should know is factors. What are factors? Write the word factors. Right? Factors are numbers that when multiplied give you the product. In this case, the product is 90. The answer is 90. So we need to list all the factors of 90. What two numbers will give us 90? So we can make a list. So I'll lift this up here. Make a little box. Right? Well, we know that 1 times 90 is 90. Right? 1 times 90 is 90. So then we can go down. We can go to the next number, 2. Does 2 go into 90? Yes, 2 times 45 is 90. So as you can see, as this row gets higher, this row will get lower, so you won't miss anything. So then what about 3? Well, 3 times what is 90? 3 times 30. See how the numbers are getting closer to each other? Then we have 5 times 18. 5 times 18. Do you know another one? Well, what about 6? 6 times what? 6 times 15. And do you know are there any other factors of 90? What about 9? So let's do a couple more over here. Write that down. What about 9 times 10? That's 90. And by the way, you can see there's no more numbers because we're just talking about whole numbers now, not any decimals. So these are all the factors of 90. All right, so here's the thing we're going to do. We need to know what number in this column, 1 to 9, is 2/5 of its length. So this will be the width. This is the length. The width, the length, the width, the length, width, length, right? So what number? We know that 2/5 of 2/5 of 90 is not 1. 2/5 of 45 is not 2. And let me just show you why. Let's bring this up. 2/5 of, remember, of is times. 2/5 of 45. That's how we do it. 2/5 of 45. We did this before with multiplication. So if you multiply, 2 goes in the 45 9 times, 5 goes in the 5 once, you get 18 over 1. 2/5 of 45 is not 2. It's 18. It's too much. What about 2/5 of 30? Try that one. Try 2/5 of 30. Bring it up here more. 2/5 times 30. Do you think that will be 3? Well, 5 goes in 36 times. 5 goes in the 5 once. You get 12 over 1. Nope, that doesn't work. Which one do you think does work? If you did 2/5 of 18 or 2/5 of 15 or 2/5 of 10, will you get these answers? Which one do you think works? Well, if you looked at this one works. Let's see. 2/5 of is times 15. Right? So 5 goes in the 5 once. 5 goes in the 15 3 times. 3 times 2 is 6 over 1, which we know is 6. So 2/5 of 15 is 6. It works. So the dimensions, bring it back down here, the dimensions is 6 by 15. And 15 times 6 is 90. So we guessed and we checked, and that's how we got the answer. Now you should rewind the tape and see what I did with that, but we'll do a couple more. Let's do an easy one first, so make sure we're getting this, right? We'll do another rectangle or square, doesn't matter. Well, actually, square would be easier. So let's say that I said that the area was 20 feet. And what's missing? What should area always have? It's 20 feet squared. So we have our width, we have our length. We know that the width times the length has to be 20. So what are the factors of 20? Well, we have 1 and 20, right? We're doing the width first. 1 by 20. We have 2 works, right? 2 by 10. And then we have 4 by 5, right? You can see once the numbers are 1 away from each other or the closest to each other, then we have no more factors. These are all the factors of 20. And again, we'll talk more about factors later on in other videos. So now let's have a question. Let's say that the length, here's a question, the length, this guy. Let's say the length is 1 1/4 times greater than the width. 1 1/4 times greater than the width. So what is 1 1/4? 1 1/4 is also 5/4. How did I get that? How is 1 1/4 5/4? Well, 4 times 1 is 4, plus 1 is 5. So the length is 5/4 of the width. If you have in the numerator is bigger than the denominator, you know what that means. It's bigger, right? It's bigger. Well, we don't say bigger, we say greater in math, right? So now, if the length is 5/4 the width, what do you think we should do here to find the width? Well, let's divide. What if I said 20 divided by 5/4? Will it be 1? Well, let's check. So what do we do with division? Right, we're going to say 20 over 1 times, remember in division, we change, we keep changing, we flip, we do the reciprocal. We've done this before. 5 goes into 5 once. 5 goes into 24 times, and we get 16. So, no, 16 doesn't work. It's too big. We're trying to get 1. So which one would work? What do you think would work if we divide? If we divide the length, we should get the width. If it's 5/4 greater. Okay, well, let's make some room here. What about 4 and 5? 5 over 1 divided by 5/4. We're trying to get 4. Will it work? Keep. We're going to keep this. Change. Change to what? Multiplication. And then flip it around. Do the reciprocal. And guess what? You can cancel the 5s. You get 4 over 1, which is 4. There it is. 4 and 5 work. So 4 and 5. 5 times 4 is 20. By the way, you didn't have to divide. You could also have taken the width, bring it up here, we'll say 4 over 1, and times it by 5/4. And you just cancel the 4s, and you get 5 over 1, which is 5. So you could have times, or you could have divided. Let's do one more. Okay, so in this case here, let's say the box is flipped around, right? You're looking at it in a different way. So now this is the width, and there's the length. Doesn't really matter, right? And let's say that you already know that you have 180 square feet. That's the area, right? But we need to know the dimensions, right? So let's get the factors of 180. So we'll put the factors of 180 over here. Could be a lot. See which ones you get. We'll start off. We have 1 and 180. That's a factor, right? 2 goes into 180, goes in 90 times. List the rest. Well, who used 3? Right? 3 works. 3 goes in at 60 times. See, the numbers are getting closer to each other. As the width gets larger, the length gets smaller. That way you don't miss a number. What do you think? 4. 4 works too. 4 goes in 45 times. And 5? What about 5? Well, 5 goes in 36 times. So what others? What others are missing? Okay, how about 6 and 30? What about 8 and 10? And let's add a little more to this. Ran out of room. 9 and 20. Well, not 8 and 10. 8 and 10 is 80. A little error there. Double check your work. Always double check your work. Not 8 and 10. But 9 and 20 work. And 10 and what? 10 and 18 work. Are we missing any? Well, there's also 12 and 15. So those are the factors, right? 8 doesn't go into 180 evenly. So now let's have a question with this. We have all the factors. Let's list the question. Let's say that the length, again, is 1 1/4 times greater. So that would be 5/4 again, remember? So if the length is 5/4 greater than the width, that means it's longer than the width, what would be the dimensions? Here are our factors. Try to figure it out. I think 12 and 15 is going to work. So who thought 12 and 15? Good. So let's use 12 and 15, see if it works. So if we use 15, we'll put 15 up here. 15 over 1 divided by 5/4. We got to get 12. Our answer has to be 12 for this to work. So again, we change, and we do the reciprocal. We flip. Right? We got 4/5. And 5 goes into 15 3 times. 5 goes into 5 once. And you get 12 over 1. So it works. The answer would be 12 by 15. Remember, width comes first. 12 by 15. 12 by 15. You could have also just times the width, right? So we have 12 over 1 times 5/4. 4 goes into 12 3 times, and you get, and 4 goes into 4 once, and you get 15 over 1, which is 15. So if we use the width, we got 15, and if we use the length, we got 12. So it's 12 by 15. All right. So rewind the tape if you're a little confused. Sometimes when you watch it twice, it comes easier, especially in math. You have to see it a lot. Okay, great job.